All right, let's get into it. You know, when you think about the outer solar system, your mind probably jumps straight to Jupiter's Great Red Spot, or, those incredible rings of Saturn. But way, way out of the edge, there are two planets that they don't play by the rules. We're talking about Uranus and Neptune. And yeah, they get grouped together all the time, but as we're about to find out, they are the solar system's true odd couple.
You know, for centuries, astronomers just kind of pictured these planets as, well, serene, icy giants. The thinking was they were just colder, maybe less exciting copies of Jupiter, just drifting out there in the dark, predictable, following the same rules as everyone else.
Yeah, but it turns out that serene image, it was completely wrong. From the very first moment we got a good look at them, these planets have just refused to fit in. It's almost like the solar system decided to save its strangest tricks for last.
So, what is it that makes these two planets so incredibly weird? That's exactly what we're going to unpack here. We'll look at their bizarre tilts, their totally paradoxical weather, and the chaotic stuff happening deep inside that makes Uranus and Neptune the true strange siblings of our solar system.
All right, first things first. We have to get their labels right, because they're not really gas giants like Jupiter and Saturn. Nope, they're in a whole different and way more mysterious category.
So what exactly is an ice giant? Well, it's a bit of a misnomer. Don't picture a giant solid snowball. In astronomy, ices just means things like water, ammonia, and methane. But inside these planets, the pressure is so intense that these ices get squeezed into a hot, dense, slushy kind of ocean. And this bizarre internal ocean, well, that's the key to pretty much all of their weirdness.
Okay, let's dive into the first big mystery. And it's something you notice right away. The absolutely wild way these planets are tilted in space.
Get ready for this number, 98 degrees. That's the axial tilt of Uranus. I mean, think about it. Most planets spin kind of like a top as they go around the sun. Uranus, it's been knocked completely over on its side. It literally rolls along its orbit like a giant bowling ball.
And the seasons this creates, they're the most extreme in the entire solar system. I want you to just imagine this. One pole gets blasted with continuous sunlight for 42 years straight. Meanwhile, the other pole is plunged into 42 years of total freezing darkness. And then they switch. It's just unbelievable.
And this is where you really see how different they are. Neptune's tilt is about 28 degrees, pretty normal actually, a lot like Earth's. But Uranus, well, the leading theory is that billions of years ago, it got slammed by something the size of Earth. A collision so massive, it literally knocked the planet over and changed how it would spin. Forever. It just goes to show you how different their histories must have been. Okay, so their tilts are completely different. Got it. But the next puzzle is, if you can believe it, even stranger. It's all about their weather, and honestly, it makes no sense at first glance.
So here's the paradox. Uranus, which gets direct sunlight on one pole for decades at a time, looks, well, kind of boring. It's almost featureless. But Neptune, which is way farther out and much colder, has the most violent, insane storms in the entire solar system. How is that even possible?
And when you look at the numbers, it gets even more confusing. Neptune is way farther from the sun than Uranus. It only gets about 40% of the sunlight that Uranus does. So less energy should mean less weather, right? I mean, that's just common sense. But with these two, common sense goes right out the window.
And here it is. Here is the mind-blowing answer. It's not about the sunlight they get. It's about the heat they generate. Uranus is basically cold inside. It radiates almost no internal heat. But Neptune is a powerhouse. It actually pumps out 2.6 times more energy than it gets from the sun. It has this incredible internal engine, left over from when it formed. And that engine is what's churning its atmosphere into total chaos.
And what does that internal engine produce? This. Winds screaming around the planet at over 2,000 kilometers per hour. These are supersonic winds, the fastest winds ever recorded in the solar system, happening on a planet that's practically starved of sunlight. It's just wild.
And that powerful internal furnace leads us to our next mystery. Because the weirdness isn't just skin deep. We have to look at the invisible forces being generated deep inside these planets, their magnetic fields.
There's a quote from one of the scientists that I think just perfectly captures it. It's as if someone crumpled a bar magnet and stuffed it inside the planet sideways. I mean, that says it all, right? Unlike Earth's magnetic field, which is pretty neat and tidy, the fields on Uranus and Neptune are just a total chaotic mess.
And when you look at the data, you see it's actually two problems. First, the fields are tilted like crazy compared to the planet's spin. We're talking 59 and 47 degrees. But even weirder, they're not even centered. The source of Neptune's magnetic field is offset from the planet's core by more than half its radius. It's just completely out of whack. So, why? What's going on here? Well, unlike Earth, where our magnetic field comes from the deep molten iron core, on these planets, the field is generated in that shallow, slushy, conductive ocean of ices we talked about earlier. And because it's so close to the surface and not centered, you get this lopsided, wobbly magnetic field that tumbles through space. It's so weird it can even cause auroras to pop up near the equator instead of just at the poles.
And, just when you think these planets can't possibly get any stranger, they do. Because deep down in those atmospheres, the pressure is so extreme that it's thought to literally crush methane molecules apart, causing it to rain diamonds.
So what does all this strangeness actually mean for our bigger picture of the cosmos? Well, it means that these planets are forcing us to completely rewrite the story of how solar systems even form and change over time.
You see, the leading theory now is that these two giants weren't even born way out there in the cold and dark. The idea is they actually formed much closer to the Sun. Then, they got caught in this chaotic gravitational dance with Jupiter and Saturn, which basically flung them outwards to where they are now. And this wasn't some slow, gentle drift. It was a violent migration that probably tossed comets all over the place and totally reshaped the early solar system.
And really, that's the ultimate takeaway here. Uranus and Neptune, they're not just some final, frigid stops on our tour of the solar system. They are a profound lesson. They demand that we expand what we think a planet can be. They prove that a planet can be a sideways rolling oddball or a stormy dynamo that's powered from deep within. They show us that the universe is so much stranger and so much more creative than we could have ever imagined. And it just makes you wonder, what other weirdness is still out there, just waiting to be discovered?